Hello everyone, welcome back to my channel. Today I am with a new unit. It is one of the simplest unit in metric in paper 1, physical science. The name of the unit is Doppler Effect. Everyone can score marks from this topic. So if you are losing marks from this topic, you are losing easy marks. So don't lose marks from this topic. All type of questions, they are very simple. If you understand, they are very simple. So you must score maximum marks from Doppler effect. You must score maximum marks from the topic Doppler effect. Doppler effect starts from Doppler effect of sound. Doppler effect starts from Doppler effect of sound. Doppler effect of sound. The definition of Doppler effect, here it is very important. The definition of Doppler effect. It is a sure 2-mark question in every exam. What is Doppler effect in sound? What is Doppler effect in sound? It is the change in the frequency of the sound. It is the change in the frequency of sound heard by the listener or observer. It is a change in the frequency of sound heard by the listener or observer when there is a relative motion between the source of sound and the listener. It is easy to understand. You can connect you to your practical life. When a sound comes towards you, you are getting a feeling of sound is increasing. When a sound moves away from you, you are getting a feeling of what? The sound is decreasing. But there is no change in the increase or decrease of sound. This is happening because of the relative motion between the source of sound and the listener. So now you can easily define Doppler effect in sound. So Doppler effect in sound, Doppler effect of sound means what? It is the change in the frequency of sound heard by the listener or observer when there is a relative motion between the source of sound and the listener. This is a sure 2-mark question, so everyone can score it. So before that, Doppler effect in sound you must define. So this is what? Change in frequency. Change in frequency because of relative motion. Because of relative motion between the source of sound. Between the source of sound and listener. Source of sound and the listener. Force of sound and listener, or you can say force of sound and the observer. Source of sound and the observer. So that is Doppler effect in sound. That is the definition for Doppler effect in sound. So another thing you have to remember, frequency and wavelength. Frequency and wavelength. So frequency and wavelength you studied in the lower class. They are reciprocal to each other. They are reciprocal to each other. That means if the frequency is more, wavelength is less. If the frequency is less, wavelength will be more. So that thing you have to remember. That thing you have to remember. Frequency and wavelength are just inversely proportional to each other, inversely proportional to each other. Which is having more frequency and which is having less frequency? If you consider red color, it is having less frequency or minimum frequency, and this is having maximum wavelength. Maximum wavelength. If we consider violet color, it is having maximum frequency and minimum wavelength. So red is having maximum wavelength and violet is having minimum wavelength. Or red is having minimum frequency, violet is having maximum frequency. So that thing you have to remember. Then in many of the questions, the diagrams are like this. In many of the questions, I saw diagram like this. What is the meaning of this diagram? If a diagram like this represents sound waves. This represents sound waves. This represents the listener and the source of sound. They are at rest. Listener and the source of sound are at rest. They are at rest. That is, there is no Doppler effect. Doppler effect takes place when there is a relative motion between the source of sound and the listener. So if there is no Doppler effect, there will be no change in the frequency. That means the frequency produced by the source, that will be same to the observer. So this diagram shows if the distance between them, if they are same, that shows there is no Doppler effect. Both the source and listener are at rest. If the diagram is like this, in some questions it is coming like this. If the diagram is coming like this, that means the separations are decreasing. This means frequency is increasing. That means the source of sound is moving towards the observer. Frequency is increasing. Frequency increases. Wavelength, that is symbol lambda, decreases. So it can ask in the objective question or descriptive question, you can find this. So this diagram shows the source of sound is moving towards the observer. That means frequency increases, wavelength decreases. Then another diagram, if it is coming like this. This shows frequency decreases. Frequency is decreasing. Frequency decreases, wavelength increases. That means the listener is, or the source of sound is moving away from the observer or the listener. The source of sound is moving away from the listener or observer. So if a diagram comes like this in the question paper, you must interpret it or you must read it like this. So this is the implication of this diagram. If the diagram in some question papers, it is like this. This means the source of sound is moving towards the left. The source of sound is moving towards the left side. The source of sound is moving towards the left side, and the frequency is increasing. So in some questions they are asking to which direction the source is moving. The source is moving towards the left direction, and the frequency is increasing. That means these gaps, these distance are decreasing. These distance are decreasing. When you count this, these distance are decreasing. Then the same diagram you can draw like this. The same diagram you can draw like this. This shows the object is moving towards right, and the frequency is increasing. So these type of diagrams are you can see in the objective and descriptive questions. So if you know the meaning of this diagram, you can do only the problems. So the diagram can come in any way. So here the gap, it is decreasing. Here the gap is decreasing. Here the gap is more. So this means the source of sound is moving towards right, and the frequency is increasing. So these diagrams you have to keep in mind. Then we can go for the numericals in Doppler effect. So for that you must know the equation. There is only one equation, but some cases are there. So in Doppler effect, the frequency heard by the listener equal to V plus or minus VL divided by V plus or minus Vs into Fs. This is the only equation in Doppler effect. So FL is what? Frequency heard by the listener. V is what? Speed of sound in air. So in most of the numericals we are discussing speed of sound in air. And its value is, it's a constant in air, 340 meter per second. In air the speed of sound is 340 meter per second. VL is what? The velocity of the listener or observer. Velocity of observer or listener. Vs is what? Velocity of the source. And V is the speed of sound or the velocity of sound. And Fs, it is the frequency of the source. So these are the variables in the equation. So FL means what? It is the frequency heard by the listener. V is what? The speed of sound in air. Its value is 340 meter per second. So many of the numericals we are seeing this. The source and the listener, they are in normal medium, that is air. So speed of sound is 340 meter per second. VL is what? Speed of the listener or velocity of the listener. Vs is what? Speed of the source or the velocity of the source. Fs is what? Frequency produced by the source. This is the frequency heard by the listener. Okay. So frequency heard by the listener and frequency produced by the source, they are different because of the relative motion of the listener and the source of sound. So this equation you must learn and you must know which are the variables there. So from this equation it is clear if VL equal to 0, Vs equal to 0, you can take as case 1. If VL equal to 0, Vs equal to 0, the equation comes like FL equal to Fs. because VL, VS are 0, then VV will cancel, VL become VF, VS. That means frequency heard by the listener will be equal to frequency of the source. That is the actual frequency of the source or the frequency produced by the source. Both are equal if there is no Doppler effect. That means what? The listener and the source are at rest. So there will be no Doppler effect. So in some numerical, some objective type questions, this case comes. So this is one of the case. Then if you consider case 2, the listener, if listener or the observer moves towards the stationary source. Here the observer is moving towards the stationary source. So here source is at rest, that is Vs equal to 0. So when the observer moves towards the source of sound, the frequency heard by the observer will be more than the actual frequency. So frequency heard by the listener will be more than the actual frequency of the source. So the equation becomes like FL equal to V, it becomes VL, V plus VL divided by V into Fs. So here V plus VL divided by V into Fs. V plus VL divided by V into Fs. So here what? Here the observer is moving towards the stationary source. So Vs is 0. That source is, speed of the source is 0. Here the numerator becomes plus. What is the reason? Here the numerator can be plus or minus, but here it will be plus. What is the reason? Because the frequency heard by the listener will be more than the actual frequency. So you must put plus here. So FL will be V plus VL divided by V into Fs. Then if the listener is moving away from the source, we can take as case 3, observer moving away from source. So what will happen? Frequency heard by the listener will be less than the actual frequency. So FL will be less than Fs. Frequency heard by the listener will be less than the source frequency. So equation comes FL equal to V minus Vs divided by V into Fs. So this equation becomes like this, and the numerator becomes minus. Then only FL will be less than Fs. So from one problem to another, you check the movement of the listener and the source. Listener can move towards the source. Listener can move away from the source. So if the listener is moving away from the source, FL will be less than Fs. And here Vs will be 0 because the source is not moving, it is at rest. So the equation comes like this. So this case you have to remember. Then if you consider case 4, for example, listener is at rest, that is VL equal to 0, and the source is moving towards the listener. Source of sound is moving towards the listener. So what will happen? The frequency heard by the listener will be more than the actual frequency. So FL will be greater than Fs. So the equation becomes FL equal to VL is 0. So V divided by V. Will it be plus or minus? It will be minus. Then only the numerator becomes less and FL value will be more. So it is Fs. So if the source is moving towards the listener, source moving towards the stationary listener or observer. Source is moving towards the observer and the listener is at rest. The observer is at rest. So here the denominator comes minus. So FL equal to V divided by V minus Vs into Fs. So that is case number 4. You can consider case number 5. Case number 5, VL is 0, that is listener or the observer is at rest, and the source moves away from observer. Then this equation becomes VL equal to VL will be 0, V divided by V plus Vs into Fs. So denominator become plus. So these are the different cases related to Doppler effect. These are the different cases related with the Doppler effect. So from one numerical to another, the cases will change. So when you have a question from Doppler effect, you read the question and check the source is moving towards the observer or the source is moving away from the observer, or listener is moving towards the source or listener is moving away from the source. So the cases can come like this. So from one case to another, the Doppler effect equation also will change. So read the question carefully and find the case from the question paper and do correctly. You will get easy marks. I am sure you will get easy marks. So these are the different equations from Doppler effect. These are the different equations from Doppler effect. In some numerical problems, they are giving medium as seawater. In that case, the speed of sound, it is nearly 1470 meter per second. It is not 340 meter per second. And the value will be given in the question paper. So don't be confused and don't put the value 340. Many of the learners are substituting value as 340. So check the medium where the Doppler effect is taking place. So if it is in air, speed of sound is 340 meter per second. If it is in seawater, the speed of the sound is 1470 meter per second. So when you do the numerical, check the medium. What you learned, we can summarize like this. Source moving towards the stationary observer. Then which are the changes taking place? When source moving towards the stationary observer, which are the changes taking place? First change is wavelength decreases. Wavelength decreases, frequency increases. Speed of sound remains constant. Pitch increases. Because pitch is measured in terms of frequency. So when a source moving towards the stationary observer, which are the changes takes place? It can ask for 1 mark question and explanation also will ask. So when a source moving towards the stationary observer, what is happening? Wavelength decreases, frequency increases, speed of sound remains constant, pitch increases. So that means when frequency increases, pitch increases. Then if source is moving away from the stationary observer, what will happen? lambda increases, that is wavelength increases. Frequency decreases. Frequency decreases. Then speed of sound remains constant. It will not change. Pitch decreases. So in different question papers, I am seeing this type of questions. When a source of sound comes towards the stationary observer, when a source of sound moving away from the stationary observer, what is happening to the wavelength, frequency, pitch, speed of sound? So these things you have to remember and you have to study. So when it is moving away from the stationary observer, wavelength is increasing, frequency decreases, speed remains constant, and pitch decreases. So these things you have to keep in mind when you study Doppler effect. Some basic questions and 1 mark and 2 mark questions are asking in the descriptive questions. So you must learn this. Then another question asking in Doppler effect is the applications of Doppler effect, 2 marks or 3 mark questions. So in Doppler effect, we are using ultrasound waves. What do you mean by ultrasound waves? Ultrasound means frequency more than 20 kilohertz. That is ultrasound. Ultrasound you are seeing for scanning purpose, ultrasound is using. So what do you mean by ultrasound? It is frequency more than the 20 kilohertz. So which are the applications of Doppler effect in medicine? So we can find out the flow of blood in blood vessels. We can find out the flow of blood in blood vessels. Another thing is that we can find out the heartbeat of a unborn baby. We can find out the heartbeat of a fetus. We can find out the heartbeat of a fetus. So these are the 2 important applications of Doppler effect. And how will you apply? In some question papers, they are asking how it is working. So here we are sending an ultrasound. We are sending an ultrasound to the blood vessels, and it is reflected from there. And that reflected sound frequency will be different from the actual wave, that is, which is sent to the blood vessel. So the reflected signal and the transmitted signal, the reflected signal and the transmitted signal, they are having different frequency. We are sending ultra waves to the blood vessels, which will reflect from there, and the reflected signal and the transmitted signal, they are having different frequency. From that you can calculate the speed of or the velocity of blood. So that is the method using there. In some question papers I saw this type of questions. So these are the applications of Doppler effect in medicine. These are the applications of Doppler effect in medicine. Next topic is Doppler effect in light. Doppler effect in light. Doppler effect in light. Doppler effect in light, there are 2 phenomena, redshift and blueshift. Redshift and blueshift. It is related to the Doppler effect in light. What it means redshift and what is blueshift? It's very simple. Each element has its own spectrum. Each element will produce its own spectrum. It is unique for an element. If you take hydrogen element, if you take helium element, and if you take iron, they will produce their own spectrum. Spectrum means what? It's an arrangement of colors or arrangement of lines. So each element produces its own spectrum. So what do you mean by redshift? Redshift means what? When you observe the stars or galaxies, we are getting light from there. And when you observe them, and if you produce the spectrum of that, and if you produce the spectrum of distant star or distant galaxy, the spectrum is shifting towards the higher wavelength. That means red. It is shifting towards the higher wavelength. So it is an implication what the stars and or the galaxies, it is moving away from our earth. So redshift means what? Redshift means the object is moving away from the observer. Redshift means the object is moving away from the observer. So redshift simply means what? It is the shift towards the red color. It is the shift towards the red color or higher wavelength when the object moves away. When the object moves away from the observer. So that is redshift. What do you mean by blue shift? When you observe some galaxies, when you produce the spectrum of that, when you produce the spectrum of light, what you got? When you produce the spectrum of that galaxy, in some spectrum you are seeing the colors are shifting towards the blue end or the lower wavelength. Blue end or lower wavelength. That means what? The galaxies or the object or the celestial object, it is moving towards the earth. It is moving towards the earth. So redshift means the celestial object is moving away from the earth. Blue shift means the object is moving towards the earth. So you know that our universe is expanding. Our universe is expanding. So that means redshift you can relate to there. Every celestial objects moving away from each other. So redshift means it is the shift of the spectral lines. It is the shift of the spectral lines to the higher wavelength, that is to the red color. So in different question papers you can see they are giving spectrum and they are asking, is it redshift or blue shift? So you check the spectral lines. And find out, are they shifting towards the higher wavelength or lower wavelength? If it is shifting towards the red line, that means redshift is there and the object is moving away from the earth. In some question, the spectral lines are shifting towards the lower wavelength, that is blue line. So that means blue shift. And the continuation will be the object is moving towards the earth or the object is moving towards the observer. So the question will be there from redshift and blue shift. They are sure questions from redshift and blue shift. So redshift simply means what? When you observe or when you, after producing the spectrum of celestial object, when you observe it, you can see the spectral lines in some cases shifting towards higher wavelength or red or lower wavelength to blue. So if the spectral lines are shifting towards higher wavelength, it is a redshift. If the spectral lines are shifting towards the lower wavelength, it is blue shift. So in the question paper there will be two spectrum and you check the two spectrum, are the lines are shifting towards the red or blue. From that you can identify it is blue shift or red shift. So there will be sure question from redshift and blue shift. They are very simple to understand and you can score easy marks from there. When I check the numericals of Doppler effect, I saw descriptive questions by giving an incident. That means the source is coming towards the listener or the source is moving away from the listener, like that type of questions, and finding the some variables there. In some numericals they are giving graph related questions. In one of the question I saw they are giving the waveform, the sound wave, and here it is pressure, here it is time. They are asking about the velocity of the observer, like that type of questions are there. So how will you solve this type of question if there is a graph like this? Here this is a sound wave. So from here you can check on the x-axis time is given. So you can calculate the time for one wave. This is a from up to here. This is the one wave. From here to here, this is one wave. From that you can find out the time for one wave. That is the time period. You can calculate the time period. Then if you know the time period, you can calculate the frequency. Frequency f equal to 1 divided by t. So you are calculating the frequency of the sound produced. Frequency of the sound produced. So what is that? Fs in the equation, frequency heard by the listener, Fl equal to V plus or minus Vl divided by V plus or minus Vs into Fs. So from the graph you are calculating Fs. From the graph you are calculating Fs, that is the frequency produced by the source. That is the actual frequency of sound. That is the actual frequency of the sound. So pressure, time graph. From that you can calculate the time period. So time period means from here to here. That is the time for one wave. Time for one wave. Don't make mistakes when you take the time period. So that is from here to here. This is the time period. So from the time period of this sound, you can calculate the frequency of this sound by taking the reciprocal. So you are getting frequency produced by the source. That is the actual frequency. So from that you can calculate FL. If the question asks what is the value of the frequency heard by the listener, or they can ask what is the velocity of the listener, or what is the velocity of the source, or you can find out what is the velocity or speed of the sound. So depends upon the value given, the unknown value will change. So if a question comes like this as a graph, pressure and time, you first calculate the time period from the graph and frequency, then you calculate the unknown value. So check the question, the movement of the observer or the listener, and find out which case is and what is the equation for that case. So the cases we discussed, and find out which case from the question and write down the equation for that. Then check the unknown value and which are the values given. So that way you can solve the numericals. It is easy to solve it. Find out the given values, whether it can be given in the question paper or from a graph you will get the value, and what value they are asking and which case in Doppler effect. So from one case to another, Doppler effect equation change. So write down the correct equation for the case, then find out the given values and calculate the unknown value. That is a method you should follow while doing numericals in Doppler effect. So this is the one of the graph related question I saw in the question paper. Another question which I saw in the question paper is like this. That is the frequency. here is the time. For example, if it is 800 and this is 600. So 800 is the original frequency. Original frequency produced by the source. From the graph it is clear. It is the original frequency produced by the source. After a time, what is happened? The frequency is changed. Did you see that the frequency is changed from 800 to 600? What is the reason? Because there is a relative motion. As time changed, when time changed, the frequency is changed. As time changed, the frequency is changed. So here it was 800. From this time to this time, it was 800. For example, 0 to 6, it was 800. Then 6 to, for example, 10, the frequency is 600. So what is happened? Why the frequency is changed? Frequency is not changing in reality. Frequency is not changing in reality. But here the frequency is changed because of the relative motion. That is Doppler effect. So here the frequency is changed from 800 Hz to 600 Hz. So 800 Hz is the actual frequency. That is the frequency produced by the source. Frequency produced by the source. Then frequency heard by the listener, it is 600 Hz. Frequency heard by the listener, it will be 600 Hz. So frequency produced by the source, it is 800 Hz, and after a time the frequency heard by the listener is 600 Hz because of the relative motion. So in numericals, in Doppler effect, you find out which are the values given. In some numericals, they are descriptive. They are giving in a descriptive way. In some numericals, they are giving a graph related question. So you must read the graph. So from the graph, you find out the values. And that values you can use it for finding the unknown value. So they are very simple. Once you practice, you will realize they are simple. So practice the problem, and this type of questions can ask from Doppler effect. Doppler effect is the one of the simple unit in paper 1, physical science. So you score maximum marks from there. That is full mark from there. Those who want to get level 7, don't lose marks from Doppler effect, because it is an easy unit. It is an easy unit. So don't lose marks from Doppler effect. Those who want to score level 7, all must score full mark from Doppler effect. Then only the level will change. There will be difficult questions in the question paper, but don't lose easy marks. One of the unit is Doppler effect. That is one of the easy unit. Don't lose marks from an easy topic. There will be tough topics, tough questions. Maybe you will make mistakes, but don't lose marks from an easy topic. So study well Doppler effect. You can score full marks from there, and when you score full marks, that will change your level. So get a good level and practice Doppler effect questions. Thanks for watching. You can make your comments in the comment box. You can share the videos to the other learners studying in different schools. So this is the end of this session. Thanks for listening to me.